Hi, I'm Paul. We're doing Leetcode must-know interview questions. Today's challenge is generate parentheses, rated medium. Sounds about right. Given n pairs of parentheses, n is the input to the method that we need to write. Write a function to generate all combinations of well-formed parentheses. Okay. Well, I guess everybody knows what well-formed parentheses means. It means you're going to have a string, and each open parentheses is going to have a corresponding closing parentheses. Now, if n equals 3, we can get 1, 2, 3, 4. We can get these 5 combinations. All right. We can do it with a backtracking algorithm. Look at the topics here. Backtracking, dynamic programming. I suppose, yeah, dynamic programming. But because the constraint's very small, n can only be between 1 and 8, it's really a brute force algorithm. To do something like this, well, what would it be? It would be, so we have n pairs of parentheses, so each string will be 2n, and at each point, as we're building up a string, we have a choice. We're going to put a left parentheses or we're going to put a right parentheses. So that's two choices. And we have two options at each choice point, and we have n choice. I'm sorry, we have 2n choice points. So it comes out to be 2 to the 2nth power, but I think that simplifies to 2 to the n anyway. It's an exponential, exponential algorithm. So it's slow. We can't handle a lot of input, but all right, what are we going to do here? We're going to write a function. This will be a recursive function. This is where we will do most of the work. And it's going to have 3 inputs. It's going to have the number of left parentheses. It's going to have the number of right parentheses. And it's going to have the current string. Now, we can speed this up a little bit by pruning strings that we know are not going to work. For example, if the count of left parentheses, that's one of the inputs, if the count of left parentheses is greater than n, it's not going to work. If the count of right parentheses is greater than n, it's not going to work. If the count of left parentheses is less than the count of right parentheses. Is that right? Then it is, no, that's not right. Sorry, yeah, that is right. Or if the count of left parentheses is less than the count of right parentheses, that is not going to work. That said, if none of those are true, then we have a choice. We can add a left parentheses and recursively execute the function, or we can add a right parentheses and recursively execute the function. What does that mean, by the way, that left parentheses is less than right parentheses? Well, for example, there isn't anything specifically that we're going to write in the algorithm to say the first character has to be a left parentheses. I mean, it does, but what's going to happen is we're just going to try to generate everything. Now, when we put a right parentheses in there as the first character, that isn't going to work. So on the next recursive call, we're going to do our pruning checks, and we are going to see that the number of left parentheses, which is 0, is less than the number of right parentheses, which is 1, and we're going to kick that out and backtrack. So all right. Well, let's see what it. I can't think of anything else to say about it. Let's see what an implementation is going to look like. All right. So I'd like to have a couple of class variables here. One would be the what are we returning here? A list of strings. So let's say list string. Or we could say result equals new array list. This is going to be our list of solutions, and I think this makes sense to have as a class variable. I mean, we could pass it around, but really it makes sense to have it as a class variable. So here's our main routine. We will set the class variable to n to n. We're going to do a solve. Now initially, like I said, the first parameter is the number of left parentheses in the current string, 0. Number of right parentheses in the current string, 0. Current string, it's empty. And then once that returns, we will return result. Okay? So here is the here's the solve method. It doesn't return anything. It just updates, excuse me, let me pull this down a little bit. It just updates the the result list. So private void solve. The inputs are int left, int right, and string s. All right, so here's the pruning. If L is greater than N, that isn't going to work. Or R is greater than N. Or, why isn't that going to work? Well, I mean, you've probably figured it out already. But in this case, let's say N is 3. Well, the number of left parentheses in each of these answers is going to be 3. The number of right parentheses is also going to be 3. If either L or R excuse me, gets to be greater than 3, then the string isn't going to work. We got to toss it and backtrack. All right. Or L is less than R. If any of those is true, we're going to bail out. All right. If L equals N and R equals N, then we will do result.add S, because that's what we want. If we get through all this and we have 3 left parentheses and we have 3 right parentheses, and they did not violate this rule here by coming in the wrong order, then we can add that as as an answer. All right. Now at this point, we've got two options. We can add a left parentheses, in which case solve left plus 1 right and s plus a left parentheses. That doesn't look good. Okay. So we'll try to solve it that way. And we'll also try to solve it this way by adding a right parentheses. All right, let's go over this one more time. So we're going to come in. Initially, we will make a call to the solve routine. There are no left parentheses. There's no right parentheses. There's no string. We come in here. We do the pruning check. If we pass, we do a completion check. And if the string is not invalid and it's not complete, then we have two options that we want to pursue. One is we're going to try to solve it by adding a left parentheses and proceeding from there. The second option is we're going to try to solve it by adding a right parentheses and proceeding from there. So let's try to run this. Compile error, result add. What line is that? 17. All right, semicolon. Compile error. Oh God, that's terrible. List string. All right, run. Okay, accepted. Good. Let's move that and submit. Where do we end up here? Well, okay, we're about 50-50. Analyze complexity. Complexity, I think it's 2 to the n. It's exponential. 2 to the n. All right. So 2 milliseconds. It's all right. Let me run it. Let me run it one more time. Submit it one more time. So sometimes it improves. Well, it didn't improve. Okay. So that's it. It's just a brute force algorithm. I guess, yeah, I guess you could call it dynamic. Is it really dynamic programming? We're not storing anything. Let me think about that for a second. Okay. I mean, I suppose it could be, I don't know. It's not usually what I think of as dynamic programming. Maybe there's another algorithm. Usually, I mean, I think of dynamic programming as, a way to avoid having to repeatedly solve the same subproblems, which is not what we're doing here. It's just like, we're backtracking, and other than that, it's brute force with pruning. So, yeah, that's it. So I hope that you enjoyed the video. Please feel free to like, subscribe, comment, and we'll see you next time.